So then, first of all, thanks for the possibility to talk here about my favorite open source project, the BNG Blaster. I work at Artbrick as a software and a network engineer, and I'm also the main developer of the BNG Blaster project. Before I go into the BNG Blaster itself, let me explain what we do at Artbrick to understand our motivation behind building a project or a tool like the BNG Blaster and how we use it internally. So here at Artbrick, we build software for disaggregated routing and access, which means that you separate the hardware from the software. So customers buy their hardware separately from vendors like UFI-Space, Edgecore, or even other vendors. And so-called white label switches or disaggregated switches, and then they can buy different network operating systems. They can just install or even change it later if the capacity, they upgrade the hardware but will not reuse the hardware, so they can then just install some other hardware, software. And this is what we do at Artbrick, and therefore we build all the network protocols from scratch. And this means we started with a base infrastructure we called the Brick Data Store. And on top of this infrastructure, we built all the applications like ISAS, OSPF, segment routing, LDP, BGP, everything from scratch. And what is unique in the disaggregated market is that we also decided to build a BNG stack. So we support PPPoE, L2TP, and all these access protocols on top of a Broadcom Q2C or Q2A switch. And we even support high availability, HTTP redirect, and even recently carrier grade NAT. And all these products and protocols you have obviously requires massive testing. And this is where the BNG Blaster comes into play. So at the beginning, we utilized commercial network test applications running on x86 servers. And these are typically licensed by port licenses, or you have seat licenses or feature licenses. So we spent a lot of money on licenses here, and it was still not enough licenses. Most of the time we are running out of licenses, so we could not test enough. And at one point we even could not do the tests on special. In July 2020, we would like to, we built IPTV support for our BNG. And IGMP joint delay measurement, they only supported on hardware, on their FPGA hardware. And then we have to decide between doing a massive investment. And I really talk about massive investment because it's FPGA hardware into their proprietary hardware, or to do something on our own. And obviously we decided to do it on our own. And after a few weeks, we could do the desired IGMP measurements. And it was good enough for us to measure this in a milliseconds, or even we don't need it in hardware with nanoseconds. So IGMP is measured something between maybe 5 to 10 milliseconds. So if it's a nanosecond more or less, doesn't matter. Software was fine for us. And this works that well that we decided to continue here. The next thing was LNS, so L2TP, because actually all of the commercial applications, they are pain if you do L2TP testing. None of them is good in L2TP. And then we added L2TP support here. And then after this, we decided to publish this on GitHub. We say, okay, make it a BSD-free license so people can do whatever they like with the software, and continue to add more and more protocols for internal use to get rid of the commercial network test applications. So we added IPoE, then layer 2 bitstream access, which is a big thing in Germany. And then after my first talk at DKNOG14 we started to add all the routing protocols so that we can do end-to-end testing. And then we added recently applications like HTTP client and server, carrier grade NAT suite, and we even scaled this up to 10 million flows. And and we continue to work on this. So we work right now more than 3 years on this. It's more than 1,000 commits, 50,000 lines of C code. And as you can see, we already had a lot of features supported. We can test almost all access protocols. We can use it for verifying legal interception. We can emulate HTTP client servers, testing NAT, do all the router protocols. We have an API, and we implemented all the protocols from scratch in user space. So which means from ARP, from ICMP, from neighbor discovery, everything was implemented from scratch, which has a reason, because we needed performance. And the second thing is we would like to have the possibility to change the behavior of every single protocol, to emulate almost all vendors in the market, and without buying almost all vendors in the market for our interop testing. And this we can do on a very small footprint. So it actually works on any modern 64-bit Linux. It even works on a Raspberry Pi 3. I tested this on a small Raspberry Pi and this model tree, which is a super low cheap compute unit. And I could utilize 32,000 PPPoE sessions with DHCP on this small Raspberry Pi. Obviously, I do not recommend testing BNGs with Raspberry Pi, but it gives you some impression that you can use a small Raspberry Pi to completely stress carrier grade BNG. So the recommendation is Ubuntu 22.04, just because we internally use Ubuntu 22.04. So it's best tested, but it's not limited to Ubuntu. So we have a lot of, it was packaged to NixOS from the community. There are people using it on other Linux. The only requirement, it has to be Linux. And it would be good if it's not a 10 years old kernel. But besides this, it's fine. There is a built-in traffic generator which supports different I/O drivers, and it's well abstracted so that the I/O mode is completely abstracted from the actual logic of the BNG Blaster. So per default, we use packet mmap for RX. This is the same API TCP dump is using, and it sends traffic via raw packets or raw sockets, but you can even say packet mmap in both directions or raw sockets in both directions. And we also support DPDK, but I would be more than happy if people contribute more drivers here, but this is what we have today. And we can, without DPDK, achieve around about 10 gigabit per second, 8 million PPS, 10 million flows, which is quite okay for our purposes. And obviously, these are not the numbers for the Raspberry Pi. So, but the scaling itself depends on your hardware and your systems. So roughly we say around about 200,000 PPS per thread is what we see in most of the normal test equipment we have. The test traffic we generate, we distribute automatically over all the threads. And the traffic itself has a dedicated header format we call the BNG Blaster header. And we also ship a Wireshark plugin for it. And in the headers, there are sequence numbers, timestamps. We need to calculate loss, jitter, and all this stuff. And since we bypass the kernel, you cannot capture with TCP dump in parallel. So the BNG Blaster is able to directly capture for you into a file. And then you can start a BNG Blaster. We can even filter. You can say capture only control traffic. So you can run it the data plane traffic, but capture the control plane traffic only. And then you have only one file with a capture of all the links. And then there's the meta header, which shows you then the interface. So you can filter per interface. It's quite handy for troubleshooting if you can capture. We have DPDK support, but we call it experimental because we only tested this on Intel XL710 with a DPDK version 22.11.4. And we still have to fight with some issues with Intel since they don't support RSS properly if you have PPPoE traffic, or if you use double-tag VLANs but not Q&Q, and these kind of things. But we have some ideas how to solve this. So, yeah. So what can you do with the BNG Blaster? I splitted this into 4 categories. So one is network hard and software vendors like us, and open source network projects like maybe people working as contributors for FRR or biorouting or GoBGP. There are many open source projects, and obviously these projects often don't have a commercial network test application as they are very expensive and not available. And maybe if you contribute, you will test at home. And here the BNG Blaster can be a big benefit. You can use it then for RFC conformance tests. You can use it for interability tests since we have a lot of config options to, let's say, emulate ISAS, but do it more like Cisco or more like Juniper or more like Artbrick. So you can configure this where the commercial network applications often is do ISAS like this commercial network application does, but I don't have these vendors in my network. And I need an application emulating more like Cisco. Scaling tests is a big strength of the BNG Blaster. So with a few clicks, you can generate a network with 2,000 or 20,000 ISAS nodes and let's say 10 million BGP routes. And then you can see how your network behaves, how your router behaves with this. And I can really stress your devices. And often people ask me, why should I scale that high in my testing? And the answer is quite simple. If you scale high as possible, you will see your bugs as early as possible. Otherwise, I have to test or run. Often you run your test, it works, everything is fine. And in your production network, you sometimes see bugs after, let's say, months. But if you test on a massive, extremely massive scale, you sometimes see bugs. You could also see on a lower scale. You just need to wait longer. And this is a good reason to test always on scale in a lab, not in production. Regression tests, robustness tests. Nice thing is, since it's for free, customers can test with the BNG Blaster, then they can open a bug report if they find an issue to the vendors, and then the vendor can use the same tool to reproduce the bug. They just need to share the config.json file, and this helps a lot if you find a bug in your network with your network vendor, and you can share the config, and they can reproduce it exactly as you have tested. I guess the most people here work for network providers and integrators, and even here, you can use it for configuration validation, test your cross configuration, or do some software upgrade validation. So you emulate your actual network with the BNG Blaster and run your pre and post upgrade scripts to the upgrade. It's very handy if you do network automation and integration. So often I see that applications are tested in a staging environment, which doesn't test the scale as you have in production. It works very well, and then they go out to production, doesn't work. And it helps you that even if you're just a developer laptop with a virtual network device, that you can easily, even on such a small setup, emulate a high scale of control plane traffic to check if your APIs even behave under scale and your application works. And it's good for training, because I guess everyone here knows that doing troubleshooting on the full scale is something else than doing troubleshooting on a low scale or on a setup without any scaling. So you cannot use logs. Even working with a full table is something different than having 10 routes on an router. So it's good for trainings. And I also see an advantage in education, so that you can do, or in your universities, they can run their IP labs on a more realistic fashion with emulating a real network compared to having 4 routers in a network and 10 routes. And yeah, I prepared a small demo here as a short recording. Therefore, I used a UFI space S9600 72XC switch. It's a Broadcom Q2C switch. Could be even edge core, something else. Connected to a service area running free radios and TACACs. On the switch itself, I run Artbrick full stack as a BNG. And then I have 2 links connected to the BNG Blaster. The one link I defined as the first link I defined the network interface function, which is just a different term for logical interface. It's just a logical interface on the routers. You have a VLAN, IP addresses. You can have even more on a link. And on these network interface functions, you can then attach routing protocols, an example. And on these routing protocols, you can then attach your emulated topologies. And the way BNG Blaster works, it generates the topologies offline before. There are tools like LSPgen or BGP dump, or you can even easily write Python scripts generating topologies for you. It's a small format, and then we have, with the LSPgen an example, you can generate easily random topologies, 10,000 nodes, and not like the most commercial networks that don't generate grid networks, because networks typically are not 10 to 10 grids. So you can say random graphs, you can give a seed to reproduce the same randomness, and you can even say the multiplier for the ECMP links, because if you do, let's say, 10,000 ISS nodes and 8 links ECMP between all the nodes, then you can really see how long your SPF can take, and then you can use this to tune your router operating system. So this is a quite handy thing. On the access side, we have VLAN ranges, and to these VLAN ranges we can attach then protocols like PBPoE or IPoE. In this example, I just created 16,000 sessions, half and half, and then you can attach traffic. And we have most of the time we actually have 2 different types of traffic here. One thing is auto-generated traffic, which means we call it session traffic. So if you enable this feature, then it automatically discovers all IP endpoints between all the sessions and the network interfaces, and automatically generates, let's say, traffic between the endpoints to verify that forwarding works. Because it's one thing to say, oh, all PPP sessions are up, but it's another thing that also all IP addresses are reachable. And then it even measures the time between a session is established and traffic is forwarding, because this time has to be very small, otherwise the CPEs are freaking out. And then I also attached 1 million traffic streams just to test that all the 1 million routes in my emulated core network are reachable. And what the Blaster is also doing is, if you configure this correctly, it can even validate that traffic is not just received, it also has received with the correct label, and these kind of things automatically for you. So this is how a config looks like. These are just a few fragments. It's just a JSON file. And then you have sections like interfaces. Here's a network interface. Here's an access interface. Here, this is meaning the VLAN range. Then you have protocol sections, and there's a lot of config options in all the sections. Here, an example, you see a traffic stream. Then there's a stream group ID mapping the access interface section to the traffic streams. And then for each session, it generates the stream out of the template. And this is a bit how it works. It's not that complicated. It's just a JSON file. So you can generate it with a template tool. You can easily share it, which is a big advantage compared to, since a lot of commercial software still have some more like a binary blob XML-like formats you don't understand and cannot template. And this is just a JSON file. It's simple. So for the demo. So this is the actual CLI of the BNG Blaster. So if you start it, it has an encompasses interface, which is handy because you can run this over a jump host. And you don't need to deal with HTTP tunneling and all this stuff. If you have only jump host SSH access, it works, it looks good. On the right side, you have your log viewer. On the left side, you see the statistics, the sessions. There are even different views. You can press F1, F7, 8, so go through the different views. So you can see a few more details here. And here you see the progress bars going up, the session traffic verified, then the streams getting verified. And one thing you see now is that 2 streams fail. So you see 2 out of 1 million streams could not be verified. So then the question is, what's wrong here? So this is a very typical case. You do a test, not everything works. And then there is a CLI in the BNG Blaster you can use. And then you can use the BNG Blaster CLI. So you have to open a second terminal window here if you do this manually. And then you can use the streams pending API. And this just returns you all the streams which have not been successfully verified. So you see the 2 streams. And then I can do a stream info command with the flow ID here. And then I get all the details about this traffic stream. And then you can see this is the stream. And you see these are all informations we have for each of the for all, let's say, 10 million streams. And then if I just copy the prefix of the streams into my router, this is now Artbrick full stack, our BNG, and the CLI of it. Then you can see that I have made a mistake because I advertised prefixes I already used as local IP addresses. And obviously the local IP addresses, they win, and the traffic goes in the wrong direction. So this is why it failed. So I just made this to show a bit the troubleshooting cases. And then, yeah, here you can see how it looks like on the other side, on the BNG side, so on the CLI. So we can even see if all the sessions are established here. So let me go a bit forward. So here you see all the sessions with the line IDs, agent remote, circuit ID. We even support almost all access line attributes in the BNG Blaster, also those which are still in the IETF, even sometimes wrong formats. We even have options to make the behavior faulty, as we have CPEs doing it wrong. So I would like to emulate the wrong behavior and these kind of things. So it's built to manipulate the protocol stack in a way to emulate what you have in your network. So then, but obviously this is not what you will do if you automate your tests. Therefore we have the BNG Blaster controller. It's also open source. And this is a tool, or a daemon, which provides you a REST API for this. So internally, we use Robot Framework to automate all our tests. And then you have a REST API endpoint to create test instances, provide the test configuration, start your tests, interact with your tests, and even download then the report files, the PCAPs, and so on and so on. And it also provides a Prometheus metric interface. And this is then how it will look like if you do this API-driven. So this is what you then do in your automation. So you can create an instance with the configuration you have defined in JSON. This is the configuration we used here. And then after you created this, you can check the status. Then you can do a start command. In the start, you can give even some parameters like logging flags, enable PCAP. And then you can do a command like BGP sessions command. And then you see the result here. These are the BGP sessions of the BNG Blaster. And yeah, this is how it works. This is then the parameters of the upper side of RBFS. So the Artbrick full stack automatically has parameters running. So we can check if the routes are also received on this side. So, but because I'm running out of time, so yeah. And yeah. The next big thing is, since in Artbrick we built carrier grade NAT on Broadcom, the first question was if we sell a product with 8 million NAT translations, or actually 4 million bidirectional streams, we have to test this. We cannot just say, yeah, Broadcom says it should work, but we have never tested. And so we extended the BNG Blaster to be able to test our NAT product. And it's something I guess a lot of people building their own NAT applications. It's a popular thing to build NAT on Linux or carry NAT on Linux. Can even use this to test their NAT application if it works on scale. And here we invented a thing like award TCP streams. So to not emulate 10 million TCP streams with a full handshake, we just use UDP streams with a TCP header. And per default, set the SYN flag. And then all the NATs I tested, they probably work fine with this. And then they can test the NAT on scale if it works. And then the NAT true flag here handles in a way that the downstream traffic does not come until the upstream traffic is received. And then we learn the public IP addresses. You can even see here in the API, if you do stream info, you see the received source IP addresses. And you can even change the TCP flags. So if you're more interested in how the BNG Blaster is used for NAT, there's also a demo on YouTube just doing half an hour just NAT with BNG Blaster. So we also support HTTP redirect or HTTP client and server. We built this for our HTTP redirect, but we also use this for NAT to have a few thousand real TCP sessions and applications. And here the HTTP server also returns the received public IP import. So in your automation, you can check the HTTP client result, and then you can even see if the IP address has changed and if this is the expected IP address and port in your automation with real HTTP traffic. This is how it looks like with DPDK. So here you see in the link section how you can define this, how you can configure CPU pinning or the threads per port. So you can configure this all on the port level to say, okay, if I have unidirectional traffic, I give on one side a lot of TX threads, but on the other side only RX threads, so you can configure this very flexible. So who is using the BNG Blaster? The BNG Blaster is used by leading network operators and network hardware and software vendors like us. It's used by Deutsche Telekom AG in their Access 4.0 project. It's used by WOPCOM with its Glasfaser Nordwest, and a lot of customers all over the world I could not name because I wasn't able to ask them. But those customers, they give me the permission to show them here. So, but it's globally used. I guess one of the first customers reached me was in Africa. They was very happy because XDR was way too expensive and Spirent and all the others. So they're even in Asia, it's very popular. And yeah, a lot of people use it. And yeah, how to start with the BNG Blaster? I provided a quick start guide. So if you go to the documentation, there's a quick start guide. And the quick start guide is just requires an Ubuntu VM, a Planck VM you can create, VirtualBox, and then you can go step by step here. You don't need a lab, you don't need network equipment. Everything is provided in steps. So the BNG Blaster emulates the PPPoE server and the client, or you do ISRS between two Blaster interfaces, or then it's also an example with GoBGP and BNG Blaster. So just that you become familiar with the configuration, the APIs, how to use it. In an environment you can all have. Otherwise, you will need a lab for this, and then it's always looking different depending on what your lab is. So here you have something you can go through. It's a few exercises, and then you get familiar with how the BNG Blaster works. But we also want you. It's a community project. It's an open source project. It's funded by Artbrick, so which means I do this in my work time. But obviously, I would be more than happy if there are contributions out of the community. We also take tickets from the community seriously and work on them. There is a mail alias, there is the BNG Blaster GitHub webpage, and we also have a matrix space for this. So, and I guess I'm in time. If there are any questions.
Yeah, there must be one. Are you all sleeping after the food?
Per Globe Connect. Just one question. Why are everyone not using this? It sounds like the perfect system, and this is the first time I hear of it.
Sorry?
This is the first time I hear of this system. Why are not everyone using it like Wireshark? Is that your marketing department?
Yeah, I guess one thing I realized is the name was not the name BNG Blaster implies for a lot of people it's just for BNG testing. And then if they have not a BNG, they oversee this project. This was a big mistake in this project to name it BNG Blaster. And now, in the beginning, it was just a BNG tester. But now it's a complete router tester. And all the non-BNG folks, they just skip the web page. Oh, it's BNG. I don't have a BNG. Yeah, this was a big problem here. Yeah. So, but I would not rename it.
Henrik Kramselund from Security. So looking forward, what would be your on your wish list for the next hardware that you would use for next step testing? I guess the next platforms will be bigger, bigger, bigger. So what will be the wishing list for the next PC for running this?
Oh, okay. Yeah. What I see definitely is I see a big advantage of having single core performance. So it works very good in gaming PCs because you have a high single core performance, and having a lot of cache still works. So the normal PCs work very well. And as all network close applications, it works better if you have just one NUMA node. Otherwise, you always have the problem if your application runs on NUMA node 1, your NIC is on NUMA node 0. Yeah, these kind of things. So, but it's like you have to deal always with DPDK and other stuff. It's the same requirements. But I'm quite happy with normal hardware right now to test. So next big thing is more like from the NIC vendors. I hope that I can get better smart NICs, which are easier to do RSS. Yeah?
Oh. I left too early. No problem. I bought some DPU2 NVIDIA Mellanox cards. Have you looked into those?
It's on my list to do it more. Because with Intel, we have some issues. So next step is to look if Mellanox performs better here.
Okay.
Yeah.
If you want to try some, let me know. We can.
Yeah, maybe we can talk later. Yeah.
Any other questions? Oh.
Hi, Jan from Nordlys. When running the test with traffic, do you support testing with different packet sizes as well?
Yes.
Yes.
Yeah.
How about setting DHCP or 802.1p markings if you want to test?
Yeah,
QoS
also
setup?
supported.
Great, thank you. Great presentation.
Okay. I think we've run out of questions. So let me gift you with this nice colored box of chocolates.
Thanks a lot.
And thank you very much.